name. I know he's actually not.
That's different.
Darcy? Mr. Darcy?
Goodness gracious.
But I like him in this genre. I like him being like the dude that sacrifices the stuff, but like actually cares. You know?
I just like that. He seems like a cool guy. I was saying I was like, I was watching it. I was like,
Donut. Yeah. Oh, no, thank you. I just had some salty pretzels. You know, Mr. Lockyer said that when the teachers got together, we were all talking about chili because we like chili. And he said that where he comes from, Wisconsin, whenever they make chili, you always eat it with cinnamon rolls.
Cinnamon rolls?
What's wrong?
That's disgusting.
I mean, you keep them separate, but you serve them
that is
together.
like- No,
Because he's a north.
that is now
Yankee.
one of the deadly sins.
Same way.
Yeah.
That is now one of the deadly sins. That is just.
Is it like as a dessert? Like that?
No, I think it's like.
No,
bread.
it's an
Like
ed.
you eat chili and then a piece
Like
of
instead of cornbread, it's like
I-
cinnamon roll.
Yeah, maybe.
That's something. I mean, I was shocked.
I'm willing to try it. It's kind of like bacon, you know, cinnamon roll goes with anything.
I don't like.
Or like really
How it
sweet
tastes.
cornbread, you know, like the I love cornbread. Oh, me too.
But like,
Mhm.
The best.
If y'all get quiet and work on your worksheet, I'll put Christmas music on. Let's see, educate. Physics.
I mean, I'd be kind of impressed, but yeah, but something happened. Yeah. You need a lot of work. Wait, I'm on page.
I've got a key for the first 2 pages for just the number problems. Which one? Are you raising your hand? No, just scratching your head. Okay. Yeah.
The skinny one.
Oh, you thought?
what? You don't think it's new? Were you talking about the other one?
I don't know about either of them.
Which one were you talking about?
I said Blake looks like a fun guy. Like I want to be friends with Blake.
Oh, yeah, no, he looks funny.
Why? What's wrong with you? Blake's just like he's like a chum. Just like
Yeah, but she's like a dumb chum. Not the good one, the dumb chum.
Okay, got ladies, back to physics. Physics, ladies. You can talk about that while you make your placemats in house. Mhm. Yes. Oh man, I had it up there yesterday, but I will put it up again. This is delta figure 2 regular heat section together. We'll make that fine. Okay. $16, right? It's heading due south at 125. And you can just leave it in kilometers per hour. And there's a steady wind from the southeast, that's this way, at 25 kilometers per hour. So 1, 2, 3, 4, probably even a little more. So that's kind of almost to scale. It's pretty massive. You don't have to draw that extreme though. And so his heading will be like this. And we know that this is 45 degrees because it was exactly southeast, blowing southwest. So you need to use law of cosines. And that's important, but so this angle, you know it, and then you're in its opposite this, so you can apply it, okay. And make sure you're in degree mode. And then you also have to do, you need to give me a direction because they ask for a vector. And the easiest way to do that is just to label this as theta and solve. Well, I already called 45 theta. So I'm going to call this one alpha. Okay, so if you label that alpha and then solve for alpha, that'll be good enough.
How do you solve for alpha?
Okay, so there you got to use your law of sines. And that would be alpha. No, we do the 25 over the sine of alpha equals. You have this one because you don't know that. You don't know this angle, so you can't use that. Yeah. And so R over sine of 45. So once you find R, you can put it there and then solve for alpha.
Okay.
And I got 9.3 degrees, which I was thinking that was a little off, but then when I looked at it, it should be pretty small. And I haven't double checked my answer, so if yours don't match with this, I'll double check it.
Do you need to find like the force being pulled down on M2 and then the friction force of M1?
Yeah, and yeah, because there's friction. Yes.
And then to tell if it's moving, how would you tell if it'll accelerate when it's
Okay,
released?
so you have to find the friction force using the coefficient of static friction.
Mhm.
Or do you have, yeah, the coefficient, yeah,
That'll be like
yeah, so they give you that. Compare that to the weight.
of this.
Uh-huh.
Oh,
And so if the force of friction is more than the weight, it won't move. But if the weight's more than the coefficient, I mean, this friction, it will move. So you got to
Like-
find the friction force.
and then this is like FWMG.
Yeah,
Oh, okay.
exactly. And you have the equation for mu, the coefficient, yeah. So would y'all like Christmas music as in Trans-Siberian Orchestra? Yeah, okay. What is that? What do you mean? How can you go to Annapolis and not even know? Okay, I'll start with this one.
It just doesn't fit the genre.
It didn't even sound like Christmas. I was like, what is this?
Oh, nice. Gladly. Figure that out. Whoa, that was too much. Is that too much? Inspires? Oh man, you may have to. Oh, it's kind of low, but it's working. Let's see if this one has more of a charge. Oh, this one's about to go out. If it does, oh, and now it's, we just went red. If it does, the charger's over here, and you could, at least it was over there anyway.
Thank you.
I'll start charging this one. What? Where is it? Where did? Hang on, I just remember where my charger went because Brandon was using it and he came and got his calculator. But it's not there now. Yes.
This one, I understand this because I should have subtracted that. But what did you mean when you circled this and put it down there?
Yeah.
I don't know if you know.
What question is that?
It's
The same as.
39 on this one.
So you're doing B. What's that? And you do an R. You do R first. Oh, for the. So what are we doing here?
This should not be 307 because I added that instead of subtracting it. But
So what did I mean? In here, you're just listing what the values are given, right?
yes.
And so then you did R, and then oh, okay. You just have F right here. It's supposed to be R times F. So you have to do R times F times the sign.
Isn't that what that is though? Because F is the 6.85
What's R?
and then the R is the.
Well, you didn't show that you were multiplying it here,
Oh, okay.
did you?
I multiplied it, but I didn't like show the work of me doing that.
Does it get the same, the right answer?
Yeah.
Oh, 1 point, and this is 6. Okay, these are different numbers. Oh, I see. I think I was just looking at the 685 and saw 685 and thought they're in the 10 to -5, and thought these were the same numbers. I don't know why. That's probably what happened.
But you took the points off for that.
For that,
right?
yeah,
Okay.
yeah,
just
because I
making
was,
sure.
yeah, because that was the answer. I wouldn't take it off.
Okay.
Yeah, this one gets tedious to me, so I'm gonna forward it. We know what you might. Okay. That's not what I'm listening to. Okay. Hang on. Christmas Eve and other stories. There we go.
Find out the worth of everything that his children had done since that winter night, the birth of his son. And then a sound filled the night, the cold winter air, and in the midst of his life, his holy there.
We listened to that one already. They were all instrumental less period. What the heck? Oh, okay. There we go. Okay, that's an F course. Yes.
On 17, yes, 17. Did I set this up right?
What's that? Oh, I didn't put that one up there. Okay. Yeah, there he is. Yes. Yeah.
So why would his velocity be right here instead of right here?
He's trying to go this way.
Mm-hmm.
So he has to aim this way and paddle at the rate that he can
The
paddle.
current's going that way.
And then the current's going to pull him down, and he'll end up doing that.
Oh, okay.
And you got the right number. Yeah.
I have a question.
Mhm.
I'm on 13.
Yeah.
I don't know where to go from here.
Okay. So this is the vertical initial velocity, and that's the no, that's horizontal, and that's vertical. Yeah. Okay. And the final velocity is not 0, because it gets launched and it speeds up, and then it slows down, and then as it's coming down, it speeds back up. But you don't really need that. But the D is 0 because as far as it goes up, it also comes back. So it comes back to the same level, right? The ground is level for a long distance. So dV, the horizontal distance, the vertical distance, dV is 0. You put that under vertical. That's a D. Yeah.
Meters per second.
No, just meters because distance. And your vertical acceleration is negative 9.8.
Why is it that?
Because that's the acceleration due to gravity.
Why is it negative?
Why is it 9.8?
Why is it negative?
Oh, why is it negative? I'm assuming up is positive and down is negative, and because you had your vertical velocity this is as positive, and that's going up. So the gravity is always the opposite of the, so if this had been negative, that would have had to be positive.
Okay.
And so you're looking for time over here, and you have a velocity, and you have a distance of 0. Yeah, so I think you can use the this one, where this is 0 distance. Your initial velocity is that vertical one. And then your acceleration is negative. And so you'll have T and T here, right? But when you multiply 1/2 by negative 9.8, this whole thing becomes negative. And so then you can move it to this side of the equation because all you have over here is 0. And then you can divide by a T. And then you can solve for what's left, the T that's left.
Okay.
So you can give it a shot.
Thank you.
This is the Mad Russians Christmas. Yeah.
Oh,
Let's put this down just a little bit more.
it's on this one because I just wasn't sure what it would. So it's on this one. Find the
Yeah,
distance from
B. Okay, so you found this is right. Okay. And so, and you, the distance to T2, this is 58,
Yes.
and you were looking for this.
Yes.
And so you would have,
This is what I started to do, but apparently that
okay,
wasn't
175 times 0.58, right, is equal to
equal
this
to.
distance times this one.
So it'd be that would be equal to 130 times. So
Times your
the 3
distance. You don't know what your distance is. That's, you have to have a variable. Because you're just doing,
So you wouldn't involve the 305 at all?
no,
Okay.
because that's your pivot. So you don't worry about anything where your pivot is.
Okay.
This distance times this mass or weight equals this distance times this weight.
Okay. That makes sense.
When is physics? Thursday. So we'll have a review on Monday, more review on Tuesday. Then we won't have class Wednesday, and then we'll have our exam on Thursday. And that's when your review is due to turn in.
I'll check on this one.
Okay. At 136, which I went through it pretty fast. So let me see. Let's see if we got the same. The X horizontal 29.1. I got rounded to 16. And BY 22.8. Yeah. And time. So I got a time of 4.6.
We're at 4.9.
No, this right here.
Oh, 4.6, yeah.
Yeah, that's the same thing I got. And then you plug that into here. Okay, but don't use the 37. Oh, you use your cosine. You know, you got to multiply it.
Oh,
And so you use the 29.
29. Okay.
Yeah, and that's probably going to make the difference.
Okay.
29 times that time. Yeah. The only time you ever use that original velocity is to resolve it into components. The only time.
How would you do the right hand rule for this one?
What angle did you use? It's a 103, good. So it's R cross F, right? So you want to point in R's direction with your right finger, but you want to get these to go toward F, but F is over there, so you have to flip your hand over.
Oh,
Okay. So it's going to be like that.
okay.
So it's into the page.
So you do whatever comes first.
That's your
where you put
index
it.
finger.
Okay.
Yeah. And then you have to, which way you're going to move to get to the other one. Either this way or that way.
Okay. Thank you.
Yeah, it's weird. Yeah. Calculus. There. Usually it's kind of hard this soon before finals. There's memory quizzes. The number devil, you have to read Flatland. Memorize the radians on the unit circle or the sine and the cosine of the radians on the unit circle. So you can look through this if you want. They got another instrumental. What did you just staple? Oh, and you kept it. Okay. Thought you put something down. Do that one. Let's do this one. Sure.
find the acceleration.
So it's gonna be based on the net force,
The what?
the net force,
The net force.
because net force equals ma.
Mhm.
So you need to find the net force, right? Well, this will be pulling down one way, and this will be pulling down the other, and so
Is FW the F, I mean, F, the force of weight is the F net.
no, it's
Uh,
the net force will be the difference between the force of this one and this one.
oh, okay.
So obviously M2 is going to be pulling harder because it's heavier.
Mhm.
So you do this times 9.8 minus this times 9.8,
Okay.
and that'll give you the net force.
Mhm.
And then when you, to get the acceleration, you're going to divide that by the mass,
Mhm.
but you want the mass of both of them, so you have to add them up.
Okay. Thank you.
Mhm. Okay, I've done all the math calculations on the key if you want to check any of them. Hmm.
Can you tell me the unit circle circle, do you mean like the actual point or what each degree is like equal to?
The radians on the unit circle. Yeah, so what degree is,
Oh,
not the sine and cosines.
oh,
Yeah. Yeah, let me put that on the board. I've had a lot of people asking about that. It was it's the grenade launcher, right? 37 meters per second at 38. And you're trying to find how far away does the grenade land? And so when you're doing your vertical and your horizontal, since it lands back level to where it started, its overall distance, vertical distance is 0. And its initial vertical, VOV, initial vertical, is going to be the sine. You need the 37 sine of 38. And
The gravity is negative because it's falling. Right?
Well, because it's the direction, right? And so since this velocity I have, it's going to come out being positive. That means I'm saying up is positive. So down is negative since the acceleration due to gravity is downward.
Oh.
Yeah. Yes.
This one.
Okay.
Would it be 5? Because I thought like I did the little like antiderivative
Mhm.
thing,
Yeah.
and you got 5 and I got 4.
Okay.
Because
So,
if you take this down, that would be 20, and then you would subtract that, and then it would be 4.
so you want to take the derivative to get the 4x. Wait, no. There's not a power rule. So what did I put?
You put 5.
5 in front. Okay, yeah. Because say if you take the derivative of e to the 4x, you'll get e to the 4x times 4.
Oh, I see. Okay, and then there was another one. Oh, here
Mm-hmm.
is it? Because once I took the derivative of this one, I brought it down, and that was negative.
Oh, no, yeah, but this is not right. So what's negative 1/2 minus 2/2?
Oh
No, I think
wait,
you're right.
minus 1.
Oh, no. Okay, here's the problem. A square root is positive 1/2.
Oh,
So
okay.
you did the derivative right, but now you gotta do it with the positive.
Okay, so then this moves down to a positive. So that's just
Yeah.
okay. I see. Okay, that's it.
Okay, so what did you get here? You got 10.96 and you're using degree mode. Okay, so I did it. I just don't remember what I got. I got 22.8. That's why, yeah, I didn't think I looked. Did you get 10.96 again?
Yes.
37. Let's find the 38. But this shows you're in radian mode. So do it again, but put a little degree sign on the, you know how to do the little degree sign?
I changed it to.
It still said radian, so. That should work. And now, but it still says radians. Yeah, I'm not sure what's going on there. Just when you type in your 38, type in a little degree sign. I think then it'll do it in degree mode. Yeah, so that's it, 22.8. That's what you put here. That makes sense, because 1/2 of 9. Okay, now since you have a negative, I'm going to move that over here and make it a positive. That makes sense? And then you can divide both sides by t to get rid of the t squared. What did I get? 4.65 seconds. Let's see, for a horizontal, I got 29.16.
They're trying to get 85. So divide. Divide. Okay, I put the ones in here that I wanted to do. I
Mhm.
put little pencil stars by them. And I was wondering on Monday I'll have like a 45-minute study hall. I
Mhm.
could just do it then.
Okay. Where did you?
It's on the first page. The ones.
Oh, here. Okay. Okay.
Those are ones we've talked about, so
Yeah.
that I actually like know.
Oh, good. Yeah. And so 3 quizzes. Daily equals 3 equals. Oh yeah. Okay.
Say that 3 was just equal to the test.
A quiz grade. Yeah. Okay. Keep this handy. All right, guys, time for house. Okay, Kate. I think we're all gonna meet over here because I've got tables and we can. So the first thing is we have to, did you read this? 'Cause I think he said it was, yeah, we have to come up with a name. Each house should select and propose an excellent epithet. So we'll have to decide among ourselves what name we want. So we'll have to like get nominations and then vote and all that. Okay. then that will be our done in. And then we're gonna have to plan what we're gonna do at the house party, which is mainly gonna be moving stuff over, but then we'll have time to, maybe we can just plan who's gonna bring what. I don't know if we'll have too much time for game or singing or anything, but
We
whatever.
can just bring simple stuff. It doesn't
Yeah.
have to be.
And then if we have time and anybody that wants to, this would be optional. So I got this stuff over here. They have, the placemats have to be this big. So they can use one of these and it's gonna get laminated. Oh man, it was wet there. Hopefully it'll dry out. Yeesh. Okay, so these are gonna dry out. And, but then they can also use construction paper if they tape, that's why I got taped out. If they tape two pieces together, it'll be the same size. And then they can use other paper for making decorations. I have some of the Christmas stickers. Huh? Yeah, all the priests are meeting in here. So if you want to, whenever you get to the making stuff, you can let me tell them what they need